Hello students, let us read this question. In each of the following cases, state whether the function is 1, 1, onto or bijective. Justify your answer. In this question, we have given some functions and we have to check whether the given function is 1, 1 or onto. So first, let us consider the first case. So we have given a function from R to R and the function is f of x equals to 3 minus 4x. So we will write First, we will consider the f of x equals to 3 minus 4x. This is our first function and it is from R to R. So in order to check for onto function, first we will check for 1 to 1 function. So here what we do is we will take any two elements from the domain and we assume that f of x1 equals to f of x2. So if after assuming that if we get if we get the condition that x1 is equal to when f of x1 equals to f of x2, if we get x1 equals to x2, then we can say that the given function is 1 1 function. So this will be equal to 3 minus 4x1 equals to 3 minus 4x2. So 3 will get cancelled from both the sides. So it will be minus 4x1 equals to minus 4x2. Minus 4x2. So again minus 4 will get cancelled from both sides and we will get x1 equals to x2. Now since we are getting this condition that x1 is equals to x2, we can say that therefore the function f is 1 1 function. Now we will check for onto function. For onto function, we first assume that our f of x is equals to y such that our y belongs to real numbers. So, uh, so our y will be equal to 3 minus 4x. So from here, the value of x will be y minus 3 divided by minus 4 equals to x. So this is our value of x. Since this is the value of x, so our f of x will become, in the place of x, we will substitute this value. So this will be y minus 3 divided by minus 4. So our original function will now become 3 minus 4 of x. So x now is y minus 3 upon minus 4. So this minus 4 will get cancelled with the denominator minus 4. We will get 3 plus y minus 3. So f of x, this plus 3 minus 3 will get cancelled and we will get f of x equals to y, which is our original condition. So therefore we can say that for every y belongs to R, there exists x belongs to R. So since it is satisfied this condition, we can say that therefore f is onto function. So we can say that the first function is 1 1 as well as onto function. Now similarly, we will check for the second function. So we have given a function from R to R and the function is f of x equals to 1 plus x square. So second question, function is from R to R and the function is 1 plus x square. So first we will check for 1 1. So here we will again assume that f of x1 equals to f of x2. So it will be 1 plus x1 square equals to 1 plus x2 square. So 1 will get cancelled. So x1 square equals to x2 square. So if we take square root on both sides, so it will be x1 equals to x2 or x1 equals to minus of x2. Now our x belongs to real number, so it can take positive as well as negative value. So we can say that since x1 does not have a unique image, so because of this we can say that f is not 1 1 function. Now we will check whether it is onto function. So for onto function, we assume that f of x equals to y such that our y will belong to real number. Therefore, 1 plus x square will be equal to y. So x square will be y minus 1, and from here x will be plus minus root of y minus 1. So and here x is also belongs to real number. So since y belongs to real number, we can take real number can take a positive as well as negative values. So if we take, if y equals to minus 3, our x will become plus minus root of minus 3 minus 1. So it will be plus minus root of minus 4. And we know that root of any negative number is not a real number. So we can say that this does not belong to real number. So here we can say that for every value of y, there does not exist a value of x, because my root of minus 4 is not a real number. So we can say that for negative value or for minus 3, the value of x is not different. And because of this, we can say that therefore f is not onto function. So using the concept of 1 1 and onto function, we have checked whether the given function is 1 1 or onto. So I hope you have understood it well, and thank you.
Don't forget to like and subscribe.